Hello, welcome to Science Excellence. Today our topic is transforming graphs, and the question number 1 is the graph of y equals to f of x is shown below, and the y equals to f of x is actually a quadratic graph, a curve of the quadratic equation with the maximum point 1 and 4, which is the turning point of this given function y equals to f of x. And the question is the coordinates of the maximum point of this curve are 1 and 4. Write down the coordinates of the turning point of the curve with the equation y equals to f of x plus 3. So the given function is y equals to f of x, and the new function is y equals to f of x plus 3. So we need to write the coordinates of the turning point of this new function. So we can see we have a change inside the function. We have the given function is y equals to f of x, and the new function is y equals to f of x plus 3. There is a change inside the function. There is actually the addition of 3 inside the function. So if there is a change inside the function, we have to do the opposite operation with the x coordinate of the given function. So the opposite operation means since there is addition of 3 inside the function, so we have to take away 3 from the x coordinate. So the turning points of the new function will be 1, take away 3, and the y coordinate as it is. So if you take away 3 from 1, we will have minus 2 and 4. So the coordinates of the turning point of this new function will be minus 2 and 4. Now the next function is y equals to minus f of x. So the given function is y equals to f of x, and if the function is y equals to minus f of x, and we have to write the coordinates of the turning point for this function, so we can see if y equals to minus f of x means minus 1 times f of x. So there is a multiplication of minus 1 outside the function, so we have to, if there is a change outside the function, so we have to do the same operation with the y coordinate. So you can see there is a multiplication of a minus 1 outside the function, so we have to multiply minus 1 with the y coordinate, since we have to do the same operation with the y coordinate. So 1 as it is, and 4 times by minus 1 will be a minus 4. So the coordinates of this new function, the coordinate of the turning point of this new function will be 1 and minus 4. Now the next function is y equals to f of x minus 3. So if we have the function y equals to f of x minus 3, so still you can see we have to take away 3, and there is a change outside the function, so we have to do the same operation with the y coordinate. That means we have to take away 3 from 4, and the coordinates of the turning point of this new function will be 1 as x coordinate as it is, and you have to take away 3 from the y coordinate, and it will be 1. 4 take away 3 is 1. So the coordinates of the turning point of this new function will be 1 and 1. Okay, the next part is y equals to minus x. Y equals to f of minus x, sorry. So if we have y equals to f of minus x, so it can be written as f of minus 1 times x. So you can see there is a multiplication of minus 1 inside the function, so we have to do the opposite operation with the x coordinate of the given function. So the coordinates of the given function are 1 and 4, so we have to divide by minus 1 with the x coordinate. So 1 divided by minus 1 and 4 as it is. So if you divide 1 by minus 1, it will be a minus 1. So minus 1 and 4 are the coordinates of this new function. coordinates of the turning point of new function. So minus 1 and 4 is the answer for the next one. Okay, so this is question number 1. Now the next question is the graph of y equals to f of x is shown below. Now the turning point is the minimum point of this quadratic curve. The coordinates of the minimum point of the curve are 2 and minus 3, and we have to write down the coordinates of the turning point of the curve with equation y equals to f of x plus 2. So the given function is y equals to f of x, and the new function is y equals to f of x plus 2. So you can see there is a change inside the function, and there is an addition of 2 inside the function, so you have to take away 2 from the x coordinate. So x coordinate is 2. If you take away 2, and we need to keep the y coordinate as it is, 2 take away 2 is 0, so 0 minus 3 are the coordinates of this new function. Okay, the part B is y equals to minus f of x. So if we have y equals to minus f of x, so this means it is minus 1 times f of x. So there is a change outside the function, so multiplication of minus 1 outside the function, so you have to do the same operation with the y coordinate. So if you times by minus 1 with the y coordinate, which is minus 3, it will turn into positive 3, so the new coordinates should be 2 and 3. So the coordinates of the turning point of the next function will be 2 and 3. Okay, so the next part C is y equals to f of x plus 2. So we have to write the coordinates of y equals to f of x plus 2. Y equals to f of x plus 2. So there is a change, addition of 2 outside the function, so you have to do the same operation with the y coordinate. So if you add 2 to the y coordinate, it will be 2, add 2 to it, minus 3 plus 2 will be a minus 1. So 2 minus 1 will be the coordinates of this function. Okay, so the last part of this question is y equals to f of minus x. So the y equals to f of minus x means f of minus 1 times x. So there is a multiplication of minus 1 inside the function, so you have to do the opposite operation with the x coordinate. So you need to divide by minus 1 to the x coordinate and keep the y coordinate as it is. So 2 divided by minus 1 will be a minus 2. So minus 2 and minus 3 are the coordinates of the new function. So if there is a change inside the function, so you have to do the opposite operation with the x coordinate, and if there is a change outside the function, you have to do the same operation with the y coordinate. So the new coordinates are minus 2 and minus 3. Okay, so we have to move now to the question number 3, and the question number 3 is the graph of y equals to f of x is shown below, and again we have a turning point which is minus 2 and 1. So the coordinates of the maximum point of this curve are minus 2 and 1. Again we need to write down the coordinates of the turning point of the curve with equation y equals to f of x minus 3. So the new function is y equals to f of x minus 3. So we can see there is a change inside the function. There's a take away 3 inside the function, so we have to add 3 to the x coordinate. So the x coordinate is positive negative 2. If you add 3, it will turn into a 1, and the 1 and 1 are the coordinates of the turning point of this new function. Okay, so the 1 and 1 is the answer for the part A. And the part B is y equals to f of minus x. So the y equals to f of minus x means f of minus 1 times x. So there's a change inside the function, so you have to do the opposite operation with the x coordinate. So that means we need to divide by minus 1 to the x coordinate and keep the y coordinate as it is. So minus 2 divided by minus 1 will be a 2. So 2 and 1 are the coordinates of the turning point of this function. Okay, the part C. Now you can see in this part we have the two different things, the minus times f of x plus 2. So the function is minus times f of x plus 2, minus times f of x plus 2. This is a function. So minus times means minus 1 times f of x plus 2. So there is a change inside the function, which is 2, addition of 2, and the change outside the function as well, which is times by minus 1. So we have to do the opposite operation with the x coordinate and the same operation with the y coordinate. So that means there's an addition of 2 inside the function, so we have to take away 2 from the x coordinate, and we need to times by minus 1 to the y coordinate. So we have to do two things. So the given point is minus 2 and 1, so we have to take away 2 from the x coordinate. So minus 2 take away 2 is minus 4, and 1 times by minus 1 will be a minus 1. So minus 4 and minus 1 are the new coordinates, are the coordinates of this new function, minus 4 and minus 1. So the part D of this function is y equals to f of minus x minus 1. So the function is f of minus x minus 1, y equals to f of x minus f of minus x minus 1. So if we, okay, let's copy this function and write it to the near of write it here, copy paste it here again. So now we have y equals to f of minus x minus 1. Okay, so we can see there is a change inside the function and outside the function as well. So multiplication of minus 1 with the x inside the function and take away 1. So we have to take away 1 from the y coordinate and divide by minus 1 to the x coordinate. So minus 2 divided by minus 1 and 1 times by minus 1. Sorry, so there is a take away 1 outside the function, so we have to take away 1 from the y coordinate, so it will be 0. So the coordinates minus 2 divided by minus 1 will be 2, and 2, 0 should be the new coordinates of this function. Okay, so the question number 4 is the graph of y equals to f of x is shown on both grids below. So there is a curve, and on the grid above we need to sketch the graph of y equals to minus f of x. So we need to sketch y equals to minus f of x, and y equals to f of x is given. So you can see there is a multiplication, there is a minus 1 times f of x, so there is a times by minus 1 outside the function, so we have to do the same operation with the y coordinates. So if you consider this point, at this point y is 5 At this point y is 4, at this point y is 3, this point y is 2, at this point y is 1, at this point y is 0, at this point y is 1, 2, 3, 4 and 5. I'm talking about only the y coordinates because we have to times by -1 to the y coordinates and the x coordinates will remain same. So if you times by -1 to the y coordinates, so all the positive y coordinates turn into a negative coordinates. So y equals to 5 turn into y equals to -5, y equals to 4 will be a -4, and y equals to 0 will be remain 0, and all the positive coordinates of y turn to a negative coordinates of y, and you will have this kind of curve. So it will reflect over the over the x-axis. So it will reflect down like that. Sorry, the curve is not properly drawn, but it will reflect down. It will reflect down like that over the x-axis. Okay, now the next part is on the grid above, sketch the graph of y equals to f of x plus 2. So you can see there is addition of 2 inside the function, so we have to take away 2 from the x coordinates. So we need to draw the graph of f of x plus 2. So we have to, the given curve is y equals to f of x. So there is addition of 2 inside the function, so we have to take away 2 from the x coordinates. At this point we have x is equal to 0, and this point should be here. If you take away 0, take away 2 will be -2, and at this point x is 1. So if from 1 if you take away 2, this point will reflect here, and at this point is x is equal to 2. So if you take away 2, this point will reflect here. So the curve will be, the new curve should be this one. The curve is not exactly drawn, but the curve will reflect on over the y-axis like that. So that's it today for today. Thanks for watching. Please don't forget to subscribe our channel, and if you want to book online lesson, you can contact on the given email address, or you can scan the QR code to book the lessons. Thank you.